This is Pranav, and this is my project 1, system calls. So the first thing I did was make changes to the Reptilian kernel. So the first file is called syscall64.table, and it contains the syscall names and numbers. I added in my 3 new syscall names and syscall numbers. So the second file is called syscalls.h, and this is basically like a header file, and I put the prototypes for the new syscalls. And each prototype uses the name that I put in column 4 of the table and has the parameters that go into the syscalls. So the third file is the sys.c file in the kernel directory, and here's where I implement the syscalls. So the first thing I do is make a global variable called a log level. And then I went to the bottom and I made these functions. So the get function is simple because it simply returns the local variable or the global variable. So the set function is harder because it actually checks if the level is good first, and it checks that the user is sudo using the capable function. And then if the level is valid and the user is sudo, then it'll set the log level. So the third function is log message, and it's the hardest. So the first thing it does is check if the level is valid, and then it makes sure that the level parameters are less than the actual log level for the system. If both pass, it logs a message, and I did the logging using the printk method or printk function, and based on this level, the code decides what branch of this if statement to take, and then it prints the appropriate message. I was able to get the executable name and PID using this current pointer, and it has access to both. So now let's move on to the library. So in process log.h, I made the function signatures, and I also assigned the new syscall numbers, 435, 436, and 437, each its own name. So then in process log.c, I implemented these functions. So these functions store the result of the syscall in an in, and then return that in. The names for the syscalls, such as getproc log, are passed into the syscall function, but these names are really just variables storing the syscall numbers. And then I did the harness functions. These harness functions make some arrays of integers, and then these arrays serve as arguments that can be passed into the syscalls directly. And these other 3 harness functions are meant to interpret the results, but it's not too bad because you can just return the parameter. So now this is my make file. There are only 2 commands, and the first one makes object files, and the second one makes the .a file. This is needed though so that the other programs can use the library, which we'll see in a bit. So this is what it looks like when I test the harness test and the library test executables. And it looks like everything passed. So now I'll talk about how I tested it. So when I finished all the code, I made a patch file and a tar.gz file, and I SFTP'd them out of the VM. Then I opened up a clean kernel and I SFTP'd these 2 files and the other set of files, the P1 testing suite. Then I applied the patch and ran make again. Then I closed the VM and restarted it. And my changes were now applied to the kernel. Then I unzipped both tar.gz files and ran make on the library and started running tests. Everything passed, but I wasn't sure if my process log.tar.gz had the right file hierarchy. And I ran the heartbeat test, which made sure that it was right. I also saw that when I unzipped it, it had the right structure, so I knew it was good. Some other tests I did were with the logging. I used send log.c to send some messages to the log, but they were pretty hard to find, so I used the grep command to search MESG, and I found the messages I sent pretty easily. So here's an example of using a test result using grep. So that's it for my project. Thank you for listening.